When we have a proportional relationship, a fraction equal to another fraction, a key method in solving is to use cross multiplication. The idea of cross multiplication is that cross products are equal. It's based on the idea that we can multiply both sides of an equation by the same number, but in essence what we're doing is that we're looking at the product multiplying one direction equaling the product we get when we multiply in another direction. So in this example, if we multiply along the yellow diagonal, we're going to get 8 times that number we don't know yet is equal to what we get when we multiply along the green diagonal, 3 times 12. So we have 8 times some number we don't know yet is equal to 36. Now our goal in this problem is to find this number that we don't know yet. Right here, our x. We have 8 times too much on this side. So what we're going to do is use an algebraic idea and a common sense idea that if we have 8 times too much, we can undo that by using the idea of division, undoing that multiplication by dividing. So what we're going to do is we're going to divide this side by 8, but to keep things balanced, we can't just divide one side by 8. We have to divide the other side by 8 as well. This is going to reduce 8 divided by 8 is 1, or just x on this side. If we have 8 times x and we divide by 8, we'll have x. And on this side, we're going to have 36 divided by 8. If we divide 36 by 8, we get 4.5. We can check this by going back to our original proportion and checking. If we check 3 times 12 is equal to 36, and if we check on our other diagonal, 4.5 times 8 is also equal to 36. We can follow the same strategy in this example, multiplying along one diagonal and multiplying along the other diagonal. We'll have equal products. So if we multiply along the green diagonal, we have 7 times 10, and if we multiply along the yellow diagonal, we have 15 times that number we don't know. 7 times 10 is 70, is equal to 15 times that number we don't know. Again, we're looking for that x value. This time it happens to be over here on the right, but it doesn't matter. We're looking for that number. So in order to find that x, notice we have 15 times too much. So we can divide both sides by 15. This will reduce to get that value of x by itself. 70 divided by 15 is 4.6, repeating all the way across the screen on our calculator. If we round, we could round that to 4.67, 4.7 if you would choose. Again, we can check that. 10 times 7 is 70, and if we multiply across the other way, 4.67 times 15 is 70.05, but remember we rounded this value of 4.67, so we have a slight discrepancy because of rounding, but we can see that our result is probably correct. In one last example, again, let's multiply across our diagonals. If we multiply across our yellow diagonal, we get 6 times that number we don't know. And if we multiply across our green diagonal, we get 9 times 7. So 6 times that number we don't know is equal to 63. Again, finding our x, our number we don't know, right here. So we're going to divide by the number with x so that we can isolate it, find out just what x is, not what 6 times x is. We can divide by 6, always dividing by the number with x. So this reduces out just to x, And 63 divided by 6 is 10.5. If we check, we know 9 times 7 is 63, and 6 times 10.5 is also 63. Notice in these three examples, we had the x in many different places, on the top, on the bottom, on the left, on the right, but the process was all the same. We cross-multiplied to get an equal relationship, and then we divided by the number in front of x. It's called the coefficient, divided by that to isolate x and find our value.